means. I don't know. I have words to use. If you choose not to hear them, then you're just messing up yourself in life. That is, when am I going to post study IQ? Bless you, Addison, for asking that. I am for sure going to post it Friday somehow. Okay, let's do number 18. This was the problem. What we've got to do is solve for x. I normally draw an arrow. Don't know how y'all are doing it. So I say 4 to the negative 2 equals x. I can't have a negative exponent, so I punish it and put it in the denominator. I know what 4 squared is. It's 16, so it's 1 over 16 equals x. Even if that's not what, Kelsey, will you bring me a calculator? Will's not here too, and I marked him as present too. Yeah, I'm on it today, let me tell you. Even if you don't know how to do logs, you can still figure them out. And God, no, not that one.
You don't want that?
No.
I was giving you
I do not like that one. And if I could, I'm not going to throw away a calculator, but yeah. You don't want it. It's that old. Even if I can't figure this one out, I could have figured it out using my calculator because I know I'm supposed to get the answer of negative 2, so I could have guessed some stuff. We talked about the other day, you can press math and scroll down to log base. So I know it's log base 4, and then I could have guessed some powers of 4, like 4 to the second is 16. So I could guess numbers that are multiples of 4. Nope, that's not right. And maybe I could have guessed my way into it. Again, it's multiple choice, so hopefully you can get your life together. Okay, number 19 has to deal with rules of logarithms. Rules of logarithms. And the problem with it is that some of us don't know our rules. If we're trying to handle this one, they both got the same base. So seriously, we're just going to set 2x plus 18 equal to 3x. Thank you for having the same base. Makes life easy. When I subtract 2x from both sides, I get 18 equals x. If you're not writing this down, you realize this is a 60% grade and I'm telling you the answers. And if you don't turn it in, I'm going to give you a 0 for it. Sad day. And when I say turn it in, if you are a senior, it's due the date of your exam. If you're an undergrad, it's due the date of your exam. But regardless, you must turn it in or I will type in a 0. And no, I will not take it late. Oh, Lord. Okay. Logarithms, when you add, and they are the same base, it's the same as multiplying, so we can write it as log 3 7x equals log 3 14. Now it really looks like our last problem. We have two logs. They have the same base, so we just set 7x equal to 14. And we get x equals 2. Bless you. As for number 21, they all have the same base. It's not written, but it's an understood 10. When they don't write it, it's an understood 10. If you want to write it, you can. When you subtract, yep. No, I'm just not. You don't have to. It's an understood 10. Say what, ma'am? Yeah, I was saying yes to that. I was waiting for you to be quiet again. It was going to be wonderful. Okay, x minus 8. When you're subtracting two logarithms, it's the same as dividing. So it's x divided by 8. So I've got 3 equals x over 8 because they have the same logs with the same base, which, again, it's an understood 10. If you want to write it, you can. You don't have to. When you multiply both sides by 8, you get 24 equals x. But, again, even if Cameron doesn't have any idea how to do logarithms, the good news is the exam is multiple choice, and now that she knows how to put logarithms in her calculator, she can probably guess it. Okay, 22 is the hardest because it involves a lot of rules of logarithms. So first of all, if there is a number out front, like there is here, you need to rewrite them as the little exponents. So I'm going to do log 5y. I'm not going to mess with him. But I'm going to write this one as log 5 r to the 4th. And need to not use this pen anymore. So I've still got the log 5y. I haven't done anything to him. I've got the log 5r, and that 4 out front is now the exponent of the r. And the same thing's going to happen with the x. It's log 5x squared. They become the exponents. That was one rule about logarithms you learned. So that's what stinks about this problem. We've done one rule, now we're going to do another rule. Since we're subtracting and they have the same base, it's dividing the term. So it's going to be log 5y divided by r to the 4th. So I dealt with these two. I've still not messed with him, so I'm going to write it as log 5x squared. I hadn't messed with him. But I ought to mess with him because they both have logs. They both have the same base of 5. Since we're adding, we're really multiplying the terms inside. So my final answer is going to be log 5 x squared y divided by r to the 4th. There are a lot of rules of logarithms you had to recall to get that one right. I bet if it was multiple choice, you might guess your way in there. Otherwise, you know you're not going to get every problem perfect in life. I hope you learned your rules of logs, but I wasn't here for that, so I can't vouch for you because I don't know. Okay, we were discussing, whoops, let me say the words again now that I got you. I'm not going to be here tomorrow. So there is no 0 period. Funny Face is due on Friday. Have you turned in Funny Face? All you had to do yesterday was click yes, I had gotten it, but have you actually turned it in? Have you shown me your angle maze from Friday? Some have not. Have you shown me the work from last week? Some have not. We started the math workshop test on Friday, and it turned out you and logarithms aren't friends. I'm going to pass that back out in a few minutes. You can work with a friend. You can ask me. You're going to turn it back in. It's going to be perfect because you want that perfect score. It's going to be great. We're going to be nice about that. In order to be nice about that, though, I've got to get out a few last words about 12.2 and 12.3. We discussed, and I gave you the study guide. You can do the study guide if you're trying to get a couple extra points. I think I'm only going to make it worth like 5 points, so it's not worth a lot. But would it help Kenzie to try this before the test tomorrow? Absolutely. I think she knows how to draw the angles, so I think she can handle the top 6. We spent the past Friday and Monday talking about that, so I think she can handle the top 6. 7, 8, and 9 is what we were discussing on Monday of if I draw an angle, like for instance, 705, if I'm trying to figure out where that is, I'm going to subtract it from what number? Yep, so I'm going to do 705 minus 360, and I get 345. So, and then I got to think about where 345 is. I bet it's over here somewhere. I'm just going to guess it really fast. So what we're saying is 705. If we drew it, it would be at this exact same spot as 345. Don't let me use this one anymore. Just throw it away for me. Yes, well, not right now. Just keep using it so you hold it. Yes, dear. Raise your hand.
Since you're posting the test like today,
yes.
Can we take it tomorrow in class?
We're still going to have, you're still going to have all of class period tomorrow. Okay. I know. Who am I right now? Okay, so we talked about that. Now flip to the back. On Monday, we were talking about how to go from degrees to radians. So I'm looking at 13 through 18. You do not have to do 10, 11, or 12. We've not discussed how to do stuff. We discussed how to convert from degrees to radians, but that's all we discussed with radians. So how can I expect you to do more? There will be no questions like 10, 11, 12 on the test. When we discussed on Monday how to convert from radians to degrees or degrees to radians, if you're going from degrees to radians, you want pi, so you multiply by pi over 180. If you're going from radians to degrees, you're trying to get rid of pi, so you divide by pi. So it's 180 divided by pi. But regardless, there's 180 and there's a pi. That's something useful to know in life. It should help you out in life. The only thing left to discuss is 19 through 24. And again, I'm doing you a disservice. So all that we're doing is leading up to something called the unit circle, and I'll show you that in just a second. But that right triangle trig you just did plays a part in the unit circle. Okay, and when you hear the word unit, what number do you think of? Unit. You think 8? I have a storage unit. How many do I have? If I have a storage, yeah, it's 1. So unit means 1. So in the unit circle, everything is a radius of 1. So these problems really aren't doing you justice. So there's this thing called a unit circle. And on the unit circle, we still have our little coordinate plane. It's like the unit circle is drawn on the coordinate plane. And everywhere on the unit circle, if you were to draw a triangle, when you draw that triangle, the radius is always 1. So on the unit circle, it's always a radius of 1. Always, always, always a radius of 1. Now, you and I both know that if when you try to figure out someone's coordinates, if we say, for instance, our first problem is 3, -4, that would mean go right 3, down 4. So I didn't pick a good, I didn't draw that correctly for 19. But just so you know, if we're trying to figure out stuff, because we're asked to find, it says the exact 6 trig values, the theta or the x or whatever the missing angle is always understood to be closest to the origin. Okay, so what happens is, well, I won't go there. So, for instance, I'm going to work your problems, but this is our end goal. Our end goal is to get to something called the unit circle, and everywhere on the unit circle, we have a radius of 1, which means my hypotenuse is always 1. On the unit circle, the hypotenuse is always 1, but sad day on the ones we're about to work, the hypotenuse is a bunch of different numbers, which is why I think they're stupid. But I guess we go over this to get you prepared to handle the unit circle, because if the hypotenuse is always 1, we can have some really weird side links. In fact, like the most common side links on the unit circle are strange numbers like square root of 3 over 2, square root of 2 over 2. Very rarely do you hear stuff like 5. It's not the kind of thing that appears on the unit circle. The unit circle has all numbers that are less than 1. Okay, so 19, though, we can still pretend and handle things the same way. So if you didn't hear any of that, that's fine. This is where we're going to, as to what life's all about. But sad day, we're never going to make it there. All you have to do on 19 is draw you a triangle using the ordered pair. So it tells you to go to 3, -4. So you know where that point is in life. Literally, so put your point and then draw a triangle. We went over 3. We went down 4. You always want the angle to be really close to the origin. So I'm going to do 19, 21, and 23. This is my picture for 19. I'm going to put my picture for 21 down here. I'm just going to draw my pictures first. On 21, they said to go to -4, 9. So I'm going to pretend that's here. We went back 4. We went up 9. I'm going to put that theta here. We'll come back and deal with it and solve it in just a second and do all the things it asks for. And so on 23, my last one, I'm going to work. Same sort of thing. It said -3, 6. So I seriously graph like normal. I would go back 3, up 6, put my point there. So I went back 3, up 6, and I put my theta here. And it's always a right triangle like usual. They asked us to find the 6 trig values. So to find the 6 trig values, we're going to need the third side of the triangle. Okay, so we could use the Pythagorean theorem, but I kind of know my triples, so I already know that if I set this up 3 squared plus 4 squared, and I'm needing to, if I set this up 3 squared plus -4 squared, and I'm solving for that third side, I already know the answer is going to be 5 just because I know my triples, but I can work it out anyway. So 25 equals c squared, so 5 equals c. So if I solve for that third side, I get 5. And this is exactly what you did on the last test, so I already know you know how to do that. So on this one, if I solve for that third side, and every time in these problems, we're always solving for the hypotenuse. So every time I put it in the Pythagorean theorem, we're always looking for that c squared. 16 plus 81 equals c squared. I don't know what that is. 97 equals c squared. So square root of 97 equals c. So on my first one, I solve for my hypotenuse. On my second one, I solve for my hypotenuse. And on my third one, I'm still going to solve for my hypotenuse. Notice that when I use the Pythagorean theorem, even though it was -3, when I square it, I still get positive 9. So I've got 45 equals c squared. So I've got square root of 45 equals c. So I did all that really fast, so let me go back through how we're connecting all the dots. So first things first, you know how to graph the point 3, -4. I graphed the point 3, -4, and then I drew a triangle. I graphed each of the respective points, and then I drew a triangle. I then solved for the third side of that triangle, and every single time I solved for that third side, I was always solving for the hypotenuse. And again, this is all helping us get ready for the unit circle, but none of these would appear on the unit circle because none of these had a hypotenuse of 1. So again, it's like we're like showing you how to make a cake and then never actually giving you the cake. It's pretty annoying, but it's the best I can do. Okay, so you're good there. And then it says 6 trig functions. Well, you've got to find sine, cosine, tangent. And then I'm out of room. You've got to find cotangent, secant, and cosecant. And I've written them in that order for a reason, because I know if I get tangent as, let's say, 3/5, then cotangent is going to be 5/3. So I've got to find the 6 trig values for each of these, which is annoying, but we can do it really easily now that we've solved for that third side. I know. And then again, I know you're like, Miss Compton, I feel overwhelmed. And I understand completely, but this test is going to be on Google Classroom. You can always watch this recording. I'm going to post a different link to help you with it. There aren't that many of these problems. Yes, you've got to show your work to get points. I guess I should say those words as well, but this is math class. I figured you knew that much. Okay, so I'm just going to solve it on the first one because I feel like I've taken over your life, which is okay. Okay, so sine is opposite over hypotenuse. The opposite of this angle is -4. The hypotenuse is 5, so -4/5. Which means cosecant is 5/-4. Cosine is adjacent over hypotenuse. Well, adjacent to that theta would be 3. The hypotenuse is 5, so it's 3/5, which means secant is 5/3. And then tangent, which is opposite over adjacent. Opposite would be -4, adjacent is 3, so -4/3, which means cotangent would be 3/-4. So I bet that you're like, Jesus, take the wheel, please let that woman stop talking. But again, it's taking all the stuff you did with right triangle trig, applying it to how you graph stuff on like a coordinate plane. So eventually our end goal is this thing called the unit circle, because that's really how we do like big girl trig stuff in life. Like if you're wanting to be an engineer or whatever it is you're wanting to do and it's going to involve math, you're going to have to know the unit circle.